Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. And so far we have looked at how to access fields of an object in Java, of a Java object in C++, how to get the values. For example, we had a person object that had a field called name, which was a type a string, and a string was a Java object, and we said that the way we access these fields and get the values in C++ is exactly the same as Java reflection API, and we get the J class that is associated with the class, and we ask the JVM to find the class on the class path, and we specify the class path description of the class, which is the package/class. And then from J class, which has the meta information of the object, we get the J field ID that is associated with this field, and we have to pass in we use the get field ID method of the JVM, and we pass the J class and then the name of the field and then the signature of the field. Here it's a Java string, so L Java/lang/string semicolon. And then we said that if we use the get double field or get int field, so the JVM has the methods get field methods for all the primitives, so get int field, get double field, get short field, get boolean field, etc. And we pass the J object and J field ID, and know that we're passing an instance of an object, right? This person is an instance of a person class, so we are passing a J object because this is an instance field, a field that is associated with the state of the person. Different person objects have different names, so we pass in a J object. So if the field is of type some sort of object, it's not a primitive type, we use the get object field, right? So this returns a field that is a object, a Java object, so this returns a J object. And then because we know the type, in this case it's a string, so we typecast the J object to J string. And then if I want to print it to the console, we said that this J string doesn't map to a primitive string type in C++, so we ask, and plus the encodings are different. Java uses UTF-16, so we ask JVM to get the actual characters, UTF characters of this J string. So this J string is just a pointer, memory address of where JVM has stored basically the string. And then it returns a const char pointer, and then we can print it to the console. All right, but note that when JVM returns a character array, it puts it on the native heap, so we have to release the memory whenever we get the characters of a string. All right, just have this in mind, that we have to manually manage the native heap. The garbage collector doesn't clean up the native heap. And then we said that accessing static fields is very similar to the instance fields, but basically we get the static field ID, and then we pass the J class, the name of the field and the signature. And then all the getter methods of the JVM now include a static keyword, so get a static double field, get a static int field, and if the field is of type of an object, then we say get a static object field. All right, so here a string name is a static field, so I'm saying that J field ID age FID is get a static field ID age, which is integer, and then J field ID name field ID, and then get a static field ID name, which is a L Java/lang/string semicolon. And then in order to get the actual value of this age, I say get a static int field and pass in the J object. No, we don't have a J object here, so we pass in a J class in this case, because the static field is not associated with the state of the object, it's associated with the class itself. So we pass in the reference to the J class, to the class itself, and then the static field ID, and this returns a J int, which directly maps to the int in C++, so get a static field ID. So if we want to get the string, the name field, which is a Java string, so we say get a static object field. All right, and then it returns a J object. We can downcast it to the J string and then get the characters, ask the JVM to return the UTF characters of this string, and the JVM puts it on the native heap, so we have to manually release this character array. Okay, Now, obviously, if we can get the fields in C++, we can also set the fields in C++. So sometimes we pass an object to C++ and maybe we want to change the value of a field of an object based on some operations that we do in C++. We want to directly change the values of a field, okay? So in C++, we take the following steps for instance fields to change the values using the set methods. Again, we have to get the meta information of the class. So we ask the JVM to find the class on the class path, and it returns the J class that contains the meta information. And then whatever field that we want to set, we first have to get the field, the field ID. If it's a static field, then we have to get the static field ID. All right. And then we pass the J class, the name of the field and the signature of the field, and then ask the JVM to basically set the field. All right. And how, you can probably guess. Instead of having get method, we use the set method. So if it's a primitive type, int, double, float, boolean, whatever, we say set primitive type field. And because if it's an instance field, then we pass in a reference of a J object and then the J field ID and obviously the value, right? And obviously the value. And then if it's an object type, the field is object, we use the set object field. And if it's a static field, we use set static object field. And then because if it's an instance field, then we pass in a reference of J object and then J field ID and obviously the J object. All right, that is the value. The value in this case is a J object because the field is an object, a Java object, right? Now for statics, all these setter methods have a static keyword, and then instead of J object, we pass in J class, and also instead of having get field ID, we have get static field ID. Okay, so I'm going to put it like this in basically the diamond brackets, saying that this is optional. So we may have, or we may use a static here depending on whether or not basically we are accessing a static field. Okay, so here's an example. I have a person class. Again, it has two fields. One is name, which is a Java object string. One is age, which is a integer. And then I have a constructor to force the setting of the name. But then in C++, let's say I want to directly change the name or set the name and change the age. So I create a J class, or I get a J class reference, so by asking the JVM to find this class on the class path. So the package here is probably test9. And then J field ID, I get the field ID of this name field, which is an instance field. It's not a static, so I use the get field ID instead of get static field ID, right? I use the get field ID. So let's also highlight this keyword, and then passing the reference to the J class, the name of the field, and then the signature of the field, which is a Java object, L Java /lang/ string semicolon. All Java objects have a signature that it starts with L and ends with semicolon. So we discussed this in much more details in the previous lectures. And then so now that I have the field ID, so I also have a reference to an instance object that I have created. So I just ask the JVM, hey JVM, this is the reference to the person object that I have instantiated, and this is the field. Set the value, set object field of this object, the name, this is the ID of the field, and this is the value, and this is a J string that I have also passed to C++. All right. If I want to change the age field and set it directly in C++, let's say I get the J field ID because this is instance field, so I use the get field ID instead of get a static field ID. So I use the get field ID, so passing the reference of J class and then the name of the field and the signature, which is I, integer, and then I ask the JVM to set int field, right? So if it was a static field, I say set a static int field, but because this is an instance field, I say set int field, and then pass a J object, which is the Java object that I've created, and then the field ID of this field, which is age ID, and then the new value, which is a JInt, right? The value in this case is a primitive type, which is JInt, which is an int. So 31, for example. All right. Just note that again, if it's an instance field, we pass in a reference of JObject. If it's a static field, we pass in a reference of JClass, which is the same as this JClass that we already retrieved, right? We need this JClass anyways, because we always get the field ID from a JClass, which has all the meta information of the class. All right. So let's head to Eclipse. So in my Java perspective, let's create a new package. So new package, let's call this test9, and in the test9 I'm going to create our person class, and let's have a string name, and these have like default level access, so package level access. I can make them private, and again, it doesn't matter. In C++ it can directly access the meta space in the memory, so without any checks, without any extra checks about security. And then int age, and then let's create a constructor, public person, a string name, and I want to set the name to name. And let's also create a string representation. So we go to source, generate to a string, and we want to create a nice representation that has the name and age information. All right, so this is our person class. Now let's create a new class, test set fields. All right, so let's have a main method, and I'm going to create a method test1, and in the test1 I'm actually going to practice Java reflection to show you how we can actually set the fields using the Java reflection. So public static void test1, and again, Java reflection API throws a lot of exceptions, and I'm just going to throw them out of the main, so I'm not going to handle them because it's not important at this point. So let's create a person, new person with the name of Bob, and then let's do a sysout on person. All right, so let's also give a default value of age 21, which is an integer. And then so at first I create an instance of the class so we are creating an we are instantiating this object person, and then let's practice Java reflection API. So I want to set the name and age. So how do I do that? Again, I need to get a class that has the meta information of this instance object. So let's call this class is person get class, and then I need to get the field. And again, this field is very similar to JField ID that we have in C++. So field, let's call it F1, is class get declared field. The name is name, and then okay, and this throws I guess two exceptions: no such field exception, security exception, and also let's throw it out of the main. And then what I want to do, so I just want to set this field value, right? F1 set, and I know that this actually is an object, right? So I know this name is a string, so instead of calling, for example, set int or set float, set a primitive, I call the set, which sets the value as an object, right? So I have to pass the reference to an object, which is my person, the object that I have constructed. So this indicates that this is actually an instance field, not a static field. And then the value is, I know that this object is going to be a string, right? This field is a string, so I'm going to say it's James. All right. And this also throws an exception, like an illegal argument exception, illegal access exception, and let's throw them out of the main. And then let's do a sysout on the person again to show you that the value of the name field has in fact changed. So if I run this, it's going to it's going to work. And again, that's because we already have the access to this field, because this has a package level access. But if I make this private, then if I run the code again, it throws an exception. illegal access exception, and the solution is to tell the API that set accessible to true, to force it to give us access to the private field. And if I run this, Bob originally has age 21, and then we change the name to James, and as you can see, our instance object person, the name has changed. Now if I want to change the age field, again the same thing, field F2. Alright, so field F2 is class get declared field age, and then but here let's also set accessible to true to force it to give us access. And then F2, I know that it's a primitive field, right? It's an integer, so I call the set int method and pass it the reference object, the person object that I have created, and the int value is 31. All right, so let's run this. So person originally is Bob with the age of 21, and now the name is James with the age of 31. So this is how we use Java reflection. So let's try to use the JNI and change the name and the age directly in C++. So how do we do that? Let's create a native method, public native void. We're not going to return anything. And let's say set name and age. And then we pass in a person and a string name and int age. All right. So we pass our instance object because we want, this is not a static method and these fields are not static, right? So we want to have an instance object, pass it to C++ and set the values there. So this is my native, and so what I need to do, let's also create a here let's create a test, public static void test2, and here I'm going to create my person again. And then now I'm going to use C++. So I'm going to instantiate this object because this is not a static method. So test set fields, test new test set fields, and then I'm going to say test set person name to James C++ and age to 31. I just want to say that this is returning the result. This happens in C++, right? So if I invoke test2 right now, it's going to throw the unsatisfied link error because this is a native method. So yeah, so it says unsatisfied link error. All right. So what do we do? Let's select our test set field that has a native method and run our, actually let's go to our C++ perspective and then run our Java H on this class, and it creates the header file and puts it here in the header folder of C++. Then I'm going to create a new source file. So let's call it setfields.cpp. And the very first thing that we do, we include the header file we just created, test9, all right. And then I copy and paste the prototype of the method, the function that we're going to implement. So the first argument is, the first parameter is the pointer to the JVM, and then the calling object, and then the next J object is the first parameter, which was a person, right? This is the J object we are passing, and then J string name and J int age, right? These are the values that we're going to use as the new values for the person fields. So step one, get the J class. So J class, basically person class is JVM, find the class on the class path. So we're going to say, and we're going to give it a fully qualified class path. So it's in the test9 package and the name is person. So this returns a pointer to the meta information on the Java heap, on the meta space. And then step two, get field IDs. Get field IDs, and we already know that these are instance field, not static field. So J field ID, basically name ID is JVM. Get field ID, this is not a static field, this is instance field. and we pass the J class reference. The name of the field is name, and the signature is L Java / lang / string semicolon. All right, so don't forget the L and semicolon, and you already see it in the signature of the method. The next one, age, is an integer, so J field ID, age ID, again JVM, get field ID for us, and again the reference to the J class. The name of the field is age, and the signature is integer. And again, you can quickly look at the method signature to see the parameter. All right, so step 3, ask JVM to set the fields. So environment set field, right? And for the string, it's an object, so I should say set object field. Set object field, which means set a field that is a Java object. So we have to pass the J object, the person that we want to actually set its field, and then the field ID is name ID, and the value, the J string, we have to pass a J object, and it's going to be name, right? So we have to pass a J object because set object field expects a J object as the field. And again, environment for the age, it's a primitive, it's an integer, right? So set int field. And for what object? For the person object, what is the field ID? Age ID. What is the value? JInt. And JInt directly maps to the int primitive in C++, so 31. So that's it. So we don't need to return anything. It's void. So all we have to do is compile it. It compiles fine. Copy and paste the native library. Yes. All right. And then we go back here, load the library into memory. Static, using a static initializer, system.load library, and native C. All right. So let's run test 2. So this should work fine. So again, after we get it, after we do the set the name and age again in C++, let's also do a sysout on the person to actually see the values have changed in Java. All right, so we create a object person. The name is originally Bob. The age is originally 21. And then we send this to C++ through this method, set name and age. And we say that, okay, change the name to James C++, and then change the age to 31. All right. And then we come back from C++ to Java and look into the person object again, and we see that the name and the age have in fact changed. All right. So if I run both of these, test 1 and test 2, so as you can see, both of them work fine. And this one is from Java Reflection API. Inside the Java, here we go to C++ and then come back. All right. But again, the way we implement in C++ is very similar, is the way we use the Java Reflection API. So it's very similar because all the information is saved in the meta space, and the goal of the Java Reflection API and the JNI in C++ is to access those meta informations and then manipulate the object based on those informations. All right. So let's just quickly also try a static field. So in the person here, let's have a private static let's call this phone number 999. All right. And then so this is int. And then we can update our to a string. So source generate to a string, and then add the basically we can manually add the, actually we cannot add the phone number because it's a static, but we can change it. And so if I go back here in test 2, when I print the person to the console, I can also do a sysout on person.phone number, or I can just use the class person dot okay, this is private. Let's make this package level access. So person.phone number. So I'm accessing this via the class itself. And then when I come back, I want to also print the phone number again. And if I run it now, because I'm not doing anything with this static field, both of them have the same. But if I go back to C++ and here I create another J field ID and then phone number ID environment, but this is a static field, so get a static field ID, and the class, the name is phone number, and the signature is again int I, right? So it's an integer. If it's double, we pass in D, capital D, but here it's an integer, so we pass in I. And then the only thing that we need to do here, ask the JVM to set a static int field and then pass in the J class. Now here we don't pass the J object, we pass a J class, and we already have it, it's the person class. And then the field ID is phone number ID, and the value, let's say 111. All right. So the main difference between a static and non-static set field is that for the non-static we pass the J object reference. For the static field we pass the J class reference. So if I compile this and then copy and paste the dynamic library to our Java project, I just go back here to our Java and then run test2, and this should work. Yes. So the static field was originally 999. After we come back from Java through this native method, the phone number has changed to 111. And again, it's very similar. You can similarly implement it using Java native interface, Java reflections, if you need to access the field and dynamically change it in Java. All right. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.